Hello, gentlemen. I'm going to talk about density today. So let's start with matter. Matter has two properties. Anything that is matter has mass and volume. Mass is the quantity of matter. We measure that on a scale in the lab. It's similar to weight, except weight takes gravity into account and mass does not. So the quantity of matter, how heavy something is, and the volume is the space that it occupies. Two ways we can get volume in the lab. One way is by water displacement. So if you look at these graduated cylinders, and originally it reads 200 milliliters. You put an irregularly shaped object in it, and it reads 300 milliliters. Then you can say that the object has a volume of 100 milliliters. That's one way we'll do that. Oops. Another way we might find the volume would be if it's a regular shape. We're going to go back to geometry and we're going to use one of those equations that you learned in geometry. Okay, when we combine the two concepts of mass and volume, we get density. So it's a derived unit where we take two different quantities and put them together to make a new concept. So the compactness of matter is density. So the ratio of the mass and the volume. So if we look back at the Diet Coke and the Coke, where the Coke has sunk, it's because the mass is greater. Even though the volume of both cans is the same, the mass of the Coke is greater. There's 39 grams of sugar in that Coke, while there's only 0.1 grams of NutraSweet in the Diet Coke. So the Diet Coke is actually less dense than water, so it floats. Okay, let's do a problem. Okay, so I'll write the given and find. Sounds like you're mowing our lawn, aerating our lawn up there. Sorry about that. If we have a mass of 5.0 grams, I like to label the fact that it's mass to keep myself straight, and we get to problems that have a lot of information in them. We have volume that's in milliliters. Now remember, the mass could be in kilograms, it could be in micrograms, the volume could be in liters, milliliters, centimeters cubed, meters cubed. So all these units could vary, and then we'd have to convert sometimes to make the problem work out, make them cancel out. We're finding the density. Okay, the equation for density is mass over volume, the amount of matter per unit volume. So we're going to, in this case, we can just plug it in because we're not asked for density in kilograms per meter cubed. So then you don't have to worry about converting anything unless they ask for a different unit. So let's go in, show our work, and we put that into the calculator. You get 2.63157, which is a lot of digits, so it seems real precise. So we're not going to write all those digits down. We're going to round to the least number of significant figures. 5.0 has 2, 1.9 has 2, so we're going to round to two significant figures. 2.6. The units are grams per milliliter. So right there. Okay. All right, the next problem, find the volume of an object. When we have 6.7 grams, grams is mass, and we have a density of 3.20 grams per milliliter. Now, if we had density in grams per milliliter and mass in kilograms, then you'd have to convert the kilograms to grams before you could do this problem. We're finding volume. All right, there's two ways you can do this problem. I'll show you both ways. I like one way. Sometimes students like it. Sometimes they'd rather do it the other way. I'm going to treat this like a conversion. So I'm going to start with the 6.7 grams, and I'm going to cancel out grams on the bottom and go to milliliters. So this slash right here is the fraction bar. So this tells us that there are 3.20 grams in 1 milliliter. And now we have an equality. We can flip that fraction any direction we want so that our units cancel. Just make sure you keep the mass with the gram. So because gram has to cancel, it's on the bottom, so the 3.20 goes on the bottom. All right, and we're done. We have volume in milliliters. If it asks for liters, we could continue on and do another conversion, and then you'd be done. So when we divide this, we get 2.09375. We are going to round to the least number of significant figures, which is 2. So 2.09 rounds to 2.1. And milliliters is the unit that didn't cancel. Okay, the other way we could do this problem is to just use the D equals M over V and rearrange that equation. You could plug the numbers in first and then calculate, find the volume, but I prefer to rearrange the equation first. So when you have an equality here, the way I always remembered it is that if I want to solve for volume, I want the volume to be where the density is. So when it's an equality and on opposite ends, numerator, denominator, they can just switch places. So we can use the equation volume equals mass over density. Okay. And then you have your volume. And it's division, and that's what we did when we did the conversion method. So you're going to get the same answer. For those of you that prefer that method, this little chart is sometimes helpful to students. So how you read this MdV thing is the mass. If you're solving for the mass, then the density and the volume are multiplied. So there's like a multiplication there. If you're solving for the volume, then you see this is a slash here. The mass and the density are divided. And if you're solving for density, density equals mass divided by volume. So sometimes students like memorizing this little table, and that helps, little image, helps students to remember how to manipulate that D equals M over V, because a lot of people make errors that way. All right, that's it for now. Have a good day. See ya.